In this chapter, we will talk about pricing within the Black-Scholes framework with Monte Carlo method. So let's start. So the motivation is, as we have talked about earlier a little bit, basically when we have a model which requires the replication of randomness or sampling of random variables, Monte Carlo method is going to be quite useful, and it is also a very flexible method which you can use to price a variety of financial problems, including option pricing or some risk quantification problems. So remember that in the Monte Carlo method, we have actually an integral of the function f of x over the unit interval. And if we call this analytical value of this integration as alpha, as in equation 1, and basically we can approximate this integral by using the sample averages as a result of these function evaluations as in given in equation 2. And basically from the statistics theory and as a result of the strong law of large numbers, we know that this sample average will converge to the true population parameter is alpha as with probability 1 as n goes to infinity. And basically, if we try to calculate the variance as long as this integral is square integrable, this function f is square integrable function, then we can write equation 3. And the error here, which is the difference between this alpha hat minus alpha, this is going to be an approximately normal distributed value with mean 0, and the standard deviation will be given by the sigma divided by square root of n. So here, of course, since we don't know how to evaluate alpha, we will not know the real value of this sigma square, for most of the problems. However, the convergence rate here is going to be with proportional to this 1 over square root of n. And to substitute this sigma square, actually we can use the sample standard deviation or the sample variance. And instead of this alpha, we can substitute our estimate for this integral, which is alpha hat, as a result of n number of samples that we generated. So basically, here the summary is in the Monte Carlo simulation, we can observe the error to decay or converge to 0 with the big O 1 over square root of n. Okay, so we can verify this in our Monte Carlo simulations, and as we increase the sample size n, we should notice the convergence rate to be proportional to 1 over square root of n.